Good morning, everyone. Good morning, everyone. On behalf of Vidyalankar Institute of Technology and Computer Engineering Students Association, I, Professor Suja Jayachandran, welcomes you all to the webinar on TensorFlow. It gives me immense pleasure to introduce our guest of honor for today's event, Mr. Jason Myers, sir. Thank you, sir.
Nice to meet everyone today.
He is Senior Developer Advocate for TensorFlow Research and Machine Intelligence. He is Web Engineer and Creative Intelligence Innovator for Google at Google. Thank you, sir, for accepting our invitation and joining us live from California. I know it is late evening over there, but thanks a lot for taking out time for us. We are looking forward for an informative session from you. Over to you, sir.
Cool. Thank you very much. It's a pleasure to be here today and looking forward to presenting. So I'm going to go ahead and share my screen. 1 second. So hopefully we can now see my slides on your side. If someone can just confirm that's presenting okay.
Yes.
Yeah. Okay. Good stuff. All right. Okay, awesome. So hello everyone, my name's Jason Mays. I am the developer advocate for TensorFlow.js here at Google, currently live from my bedroom in San Francisco, of course. And that basically means if you're exploring machine learning in the browser, in JavaScript, or anywhere it can run, there's a good chance that we'll cross paths somewhere online at some point. Now, I get asked a lot about my background as well, like how did I end up getting into this? So a very quick slide on this one here. Essentially, I started out as a computer scientist at the University of Bristol in England. I'm from England originally. And I then got into web engineering and then moved into full stack web engineering, allowing me to do design, UX, front end, back end, and all these fun things. And that was really cool because I managed to essentially prototype anything that I dreamt up because I could do the front end and the back end, which is kind of nice. And that led me to a different role at Google as a creative engineer, where I was trying to make innovative prototypes using emerging technologies such as machine learning, augmented reality, and so on and so forth. And then finally, I managed to then move into this role as developer advocate, which essentially combined my love for machine learning and my love for web engineering into one role. So with that, if there's one thing you take away from this slide, it's that I spent pretty much half my life using JavaScript. And I've got some great use cases for you today to see why JavaScript is something to consider for machine learning in the future too. So there's a question, why do we want to do machine learning in JavaScript? And essentially, if we think about where JavaScript can run, we can run it in the web browser, on server side, desktop, mobile, and even Internet of Things. And if we dive into each one of these areas even further, we can see that many of the technologies we know and love exist within these stacks. So all the common web browsers here on the left-hand side, we've got Node.js for the server-side implementation, we've got React Native for mobile native applications, Electron for desktop native, and of course, Raspberry Pi is enabled via Node.js that can run on the Raspberry Pi device. So TensorFlow.js essentially allows you to run, retrain via transfer learning, and write your own machine learning models completely from scratch, just like you can do with Python-based TensorFlow, except this is in JavaScript, and there's some advantages to that, as we'll see in just a second. And this allows you to create anything you might want to dream up, from augmented reality, sound recognition, sentiment analysis, conversational AI, all these things that you may have heard of before in Python are now possible in JavaScript as well. So there's 3 flavors of how you can use TensorFlow.js, and we're going to walk through each of these in this presentation. And the easiest way to get started is to use our pre-trained models. These are really easy to use JavaScript classes for many common use cases, and you might be surprised how far you can actually push these. Now, the first examples I want to go through are just a few of the things that we have available, things like object detection, body segmentation, pose estimation, and we can even do things like face mesh and hand pose to see where the key points on your face and hands are. and the new BERT models for natural language processing as well. And all of these can run in the web browser. So let's go ahead and see how well they work. Now, the first one I want to show you is object recognition. This is using a model called Coco SSD behind the scenes, which is a fancy name for our object recognition model. And this has been trained on 90 object classes, such as the dogs that you see on the right-hand side here. And because this is object recognition and not image classification, it means we get actually the bounding box data as well. So instead of just knowing that there's a dog in the image, we know where the dog is located and if there's more than one of them, which is very useful to know. So let's go ahead and see this in action. So I'm just going to move my other screen over here. And here is a live glitch.com piece of code that I've written to do this live in the web browser. So I can click on any one of these images, and you can see in real time, I can get classifications of the objects that's found in the image really, really fast as well. So you can imagine how you could use a technology like this to very quickly make your own smart Nest webcam or something like this. You could actually make your own home security cam very quickly to see if your dog is being naughty, eating the treats in the kitchen. You could actually write that logic very, very quickly with this kind of stuff. And just to prove how fast this runs, if I enable my webcam live right now, you can see me talking to you right now. It can classify me in real time right here at a very high frames per second, right here live in the web browser. And the really cool thing about this is that because this is running in the web browser, none of the webcam data is being sent to a server. It's all being classified, or the inference is happening all locally on my machine. And that's really good for privacy, especially when you're using webcam data or audio data. If you can do all the classification on the user's device, then privacy can be preserved as well, which is a key advantage of using TensorFlow.js in the browser. So let's go back to the presentation, 1 second. Now, the next model I want to show you is Face Mesh. Face Mesh is just 3 megabytes in size, and it can allow you to recognize 468 facial landmarks on the human face, as you can see with this animation on the left-hand side here. And this can be used for really creative things, such as AR makeup try-on. And in fact, Modiface, who's part of the L'Oreal group, have actually used TensorFlow.js to do this for a production use case. And the key thing to see here is that this lady on the right-hand side is not actually wearing any makeup. We're actually doing this in real time in the web browser using WebGL shaders. And she can choose the makeup to put on her lips using the little colored circles at the bottom, and we can render that to her face in real time in the web browser. So now she can try on the makeup without having to even leave her house, which is a really cool use case, especially in the current times where people are often not wanting to go out because of the COVID situation. So let's see this in action as well. I've got this live demo here for you. And you can see here that is able to classify me in real time in the web browser here on the left-hand side. And because this is JavaScript, JavaScript is really, really rich for 3D graphics and charting and all this kind of fun stuff. It's got much more mature libraries than some of the other languages out there. And not only are we doing the machine learning live in the web browser on the left-hand side, I'm also able to plot this 3D mesh of my face using 3.js on the right-hand side. And you can see me talking right now as I'm speaking to you in this presentation. And notice here we're getting a good like almost 20 frames per second, even though I'm actually streaming my screen and doing a lot of intensive kind of computer work right now, sending this stream to you. Without this, I typically get more like 30 frames per second when I'm not live streaming. And of course, this is running on the CPU, and it's not even on the graphics card right now. I can actually click this drop down and click on WebGL, and I can actually then get graphics card acceleration in the web browser for this machine learning model. And then I'll get closer to 60 frames per second, which is much nicer, of course. So that's a really cool model to play with. And the next one I want to show you is body segmentation. Body segmentation allows you to distinguish 24 body areas in this case across multiple bodies all in real time. And it's kind of hard for me to demo this in my bedroom because I don't have much space, but you can see from this animation here how this works. And you've got the people walking around and the webcam image on the left-hand side here. And on the right-hand side, you can see all the different colors representing the different parts of their bodies. And you even get the pose estimation, which is the bluish-green line inside of their bodies. You can kind of estimate their pose. And that's really useful because then you can potentially do pose estimation, or gesture recognition, that kind of stuff, which could lead to some really interesting use cases. In fact, in the community, I've already seen people like you making stuff like this to do yoga pose estimators, or figuring out when you're doing a workout move or something like this, so you can actually count your reps when you're doing the workouts and all this kind of fun stuff. So lots of creative potential here. And talking of creativity, I'd like to talk to you just a little bit about how you can take these models and turn them into really interesting demos. So let's see the next slide, 1 second. So here's a couple of demos I've made in my spare time. On the left-hand side, you can see how I use the body pics model to remove myself from my bedroom in real time as I get on the bed. And notice as I move on the bed in the middle here still deforms, even though I'm removed from the frame. And all of this is happening live in the web browser in JavaScript. And I actually made this invisibility demo in just 1 day of coding. So it's really flexible to take these pre-made models and then do something useful and creative with them. Now that's a fun example, and it could be used maybe for the movie industry or to do something fun in those areas. But a more practical example is shown on the right-hand side. Here, I'm actually demonstrating how to estimate my clothing size in under 15 seconds live in the web browser. I don't know about you, but I'm really bad at knowing what my clothing size is when I need to buy clothes. So now I can just stand in front of the webcam, I stand forwards, I stand to my side, and then it gives me an estimation of what clothing size I should buy on that website, small, medium, or large. So now I can buy clothes with more confidence and have less returns, which is always a good thing. But we can go further than this. You can even give yourself superpowers. Here's one guy from our community who's managed to combine TensorFlow.js with WebGL shaders. And he's managed to create these cool Iron Man-like style effects, shooting lasers from his eyes and mouth, all in real time in the web browser. And I believe he made a really cool website to do this, and you can try this out. I think it's called shaderbooth or shadertoy.com. I can't remember which one it is. It's one of those two. But you can check this out in your own time and try it out all for yourself in the web browser. And you can go even further, like you can combine it with other technologies too. In fact, this guy from Paris, also from a community, he was into fashion and stuff, and he's basically able to look at a magazine, extract the body, and then put that body into a mixed reality scene, as you can see here, and bring that body to life. And this is super, super cool because this is actually running on like a 2 or 3 year old Android phone. It's not using cutting edge phone or anything like this, but you're still able to get this really good performance and user experience by using TensorFlow.js in this context. So that's something to consider. And of course, I thought, well, why stop there? Why not teleport yourself? I don't know about you, but when I saw sci-fi movies like Star Trek and all this kind of stuff, I've always wanted to teleport myself somewhere else. And I decided to have a go at doing this. And I managed to take myself from my bedroom here and combining it with other web technologies like WebRTC, which is web real-time communication, mixed reality, 3.js, and TensorFlow.js, I can then segment myself, transmit my segmentation over the internet to a different remote location, and then that person can then place me in their room, and they can walk up to me, they can hear the sound coming from a different part of the room, and all this kind of fun stuff. So it feels like I'm really there with them. And maybe in the future, next time I give a presentation, I'll be able to actually be there in your houses with you as you listen to me give the talk, which would be super cool. So just a few ideas here of how you can be creative with all of these pre-made models, which are super easy to use JavaScript classes. Now, the second way you can use TensorFlow.js is to use transfer learning. Once you've outgrown our pre-made models, the next logical thing that you want to do is to use your own data, of course. And I'm going to show you a few easy ways to do that using TensorFlow.js. Now, of course, if you are familiar with machine learning already, either in Python or TensorFlow.js, you can, of course, do this programmatically in code as well. But today, I want to show you 2 easier ways to get started. Now, the first one is something called Teachable Machine. This is a website that allows you to train custom machine learning models live in your web browser, and it also allows you to do the inference in the web browser too. So let's go ahead and see this in action, because that's the best way to learn how to use this. And I hope that if you want to follow along, feel free. This is super easy to use, and anyone on the call right now will be able to recognize any object in their room as I speak in under 2 minutes if you want to follow along. So the website here is teachablemachine.withgoogle.com. And you can basically go to this website and follow along if you wish to. So what we're going to do today is we're going to do the image project, but it also supports recognizing audio and poses too. But we're going to click on image today. And all you're having to do here is now define the classes of objects you want to recognize. So I'm going to call the first class here Jason. I'm going to recognize my face. And then class 2, I'm going to call cards. I'm going to recognize a deck of playing cards that I've got on my desk here. So all I need to do now is give some training examples, some training data of each of these classes. And if I wanted to recognize more than 2 classes, I can click on the Add Class button at the bottom to add 3, 4, 5, or even more classes if I wanted to. But today we're just going to do 2. So you click on webcam, you allow access to your webcam, and you can see we've got this like live preview here. And essentially, I'm going to just look at the cam, and I'm going to click on hold to record and get a few different examples of my face at different angles so it can learn who I am. So here we go. Cool. So I've got about 35 images, I think it says there. And now I'm going to repeat this, and I'm going to do the same thing, but with the deck of playing cards that I've got in my hands here. I'm going to try and get the same number of examples. That's important. Otherwise, you'll have bias in your data. So let's try and get 35 of those. Well, how many is that? 34. That's close enough. So all we need to do now is click on Train Model. And what's going to happen, it's going to take that training data that we presented to it, and it's going to retrain the top layers of this machine learning model so that it can use its prior knowledge of object detection to now detect these new objects that we've just presented to it. And as you can see, in about 30 seconds, it's finished already. And this all happened live in the web browser in JavaScript. At no point did we send any of the data to the server side, which is pretty interesting. So here we can now see a live preview, and it's correctly predicting Jason, as you can see on the right-hand side here with the orange bar. Now, if I bring up my, my deck of cards, you can see this now goes to cards as the prediction. So Jason, cards, Jason, cards. And you can see how fast that is. It works in real time, and it works pretty well. Obviously, with more training data and more examples, it would be even more robust. But if you like this and it works good enough, you can click on Export Model here, and you can then export the model files. You can download them, and you can host them on your own website, which will then allow you to add your own user interface and user experience to then do something useful. And in fact, just today, I actually saw someone who used this to classify different types of recycling, like different types of plastic bottles or cans and so on and so forth. And people are using this for interesting projects already, which is really, really nice. So that's Teachable Machine, and it's great for prototyping. As you saw right now live in this demonstration, in just 2 minutes, we managed to make a custom machine learning model that does something useful. And anyone on this call can do that if they want to. Oh, let me just represent this. There we go. Cool. Now, if you have a more robust situation you want to make a custom model for, and maybe you've got gigabytes of training data, then you can use something called Cloud AutoML. This allows you to train custom vision models in Google Cloud, and all that you have to do is upload folders of images, and each folder has the name of the class of image it is. So here, someone's trying to classify different types of flowers. So they've just had lots of flower folders uploaded to Google Cloud Storage, and then you simply specify if you want to optimize a machine learning model for higher accuracy or faster prediction times. You then set a budget, and it goes away and trains for a few hours or maybe days if you want it to be really accurate. And you then get a model that you can export to TensorFlow.js at the end, as you see here. You click on Export for TensorFlow.js, and you can download the model.json files that are needed to then run in the web browser. And you might be wondering, well, how hard is it to actually use this production quality model? Actually, it's super easy. In fact, it's so easy, it fits on just one slide and just takes 3 lines of JavaScript and a little bit of HTML. So let's just go through this slide. The first line is simply importing the TensorFlow.js library at the top here. The second line is importing the AutoML library. So just some imports, nothing too fancy. On the third line here, we've just got an image tag for a new flower that we want to classify. This is just an image I've taken from the internet for now, which is of a daisy. And that's what I'm going to use to try and classify. All I want to do now is write some JavaScript code, and inside my function, all I'm doing is calling await tf.automl.load image classification, and I pass to it the model.json file that we downloaded in the previous slide. So remember, we exported here. That would download the model.json file, and then you just host that on your website and tell the code where that is located. And we use this await keyword because this is an asynchronous operation. That means it takes a non-trivial amount of time to execute because it's downloading a large file from the server. So we have to wait for that to finish before we can do anything else. So we use the await keyword to do that. And then we can get a reference to the image you want to classify. In this case, I'm doing document.getElementById Daisy, which is the image above here, this JPEG above. And then I can simply call await model.classify and pass it the image I want to classify. So in just 3 lines of JavaScript, I'll then get results coming back to this predictions object that I can then iterate through and see what was in the image and then make a useful prediction using my custom trained model that I made on the Google Cloud. So super easy to use and can run entirely in the web browser, which is super, super cool. Now, the third way to use TensorFlow.js is to write your own code. And of course, I could give a whole 1-hour presentation on how to write code in TensorFlow.js. That's a very big topic. So today I'm going to concentrate on the superpowers and performance benefits you can get by using JavaScript. Now, first of all, I want to give you a lay of the land of our APIs and how they work. So basically, TensorFlow.js is split into 2 APIs. There's the high-level layers API, which is very similar to Keras, if you're familiar with Python. And in fact, if you know Keras, TensorFlow.js layers API will be very familiar to you. It's just in a different language, but the calls and names of functions are pretty much the same. We've also got the low-level ops API, which is the more mathematical API, which allows you to do the linear algebra and all this kind of stuff if you want to get at that low-level mathematics. So you can see how this comes together. We've got our pre-made models that you saw some of those today earlier in the presentation. They sit upon the high-level the high-level layers API, and then the high-level layers API sits on top of the core or ops API. Now, this understands how to talk to different environments, such as the client side. And by the client side, I mean things like the web browser, as you see here. And each one of those environments understands how to talk to different backends, so different hardware platforms it can execute on, such as the CPU, the processor, the WebGL for the graphics card, or WebAssembly, or WASM for short, to do more efficient execution on the CPU. And depending what's available on each environment, it can automatically choose the best option for it, or you can force it yourself if you want to force a specific environment. And then the same is also true for the server side. In the server side, we can execute on Node.js, and Node.js talks to the same TensorFlow CPU and TensorFlow GPU backends, which are written in C. So it's exactly the same as Python. They're both talking to the TensorFlow C libraries, so you get the same performance benefits as you do in Python. You get the same AVX support for the CPU, and you get the same CUDA acceleration for the GPU. And in fact, we'll see why it can even be faster in Node.js sometimes later in the talk. Now, if you are still doing machine learning in Python, you can actually take saved Keras models and load them via Node.js in our layers API without conversion. And the same is true for saved models from Python. They can be loaded via our core API in Node.js without any conversion. The only time you need to convert is if you want to run in the web browser. Then we have a command line converter that you can take and use on a saved model that will convert it to the .json format that we need to use in the web browser. And that's just a command line tool you can run on any TensorFlow saved model, essentially. So that's basically the lay of the land of this. Now, I spoke about performance, and here's some good examples of TensorFlow.js in Node versus Python. And you can see here for MobileNet V2, which is a classic image classification model, you can see here how in Node, we get an inference time of 8.81 milliseconds, and in Python, it's 7.98. So this is, for all intents and purposes, the same result, because depending what the server was doing, it might be slightly different anyways. So it's within a millisecond or two of each other. And what gets really interesting is that when you take into account the pre and post processing, and for those of you who are unfamiliar with machine learning, basically all machine learning models require the inputs and outputs to be tensors, and those tensors are just a bunch of numbers. So you need to convert your data into numbers, essentially, and sometimes that can take a lot of processing or manipulation to do, and that's known as the pre-processing and post-processing. And if you convert that code to run in Node.js, we can actually see a significant performance benefit by running in Node. In fact, Hugging Face, who are very famous for natural language processing, they saw a 2 times performance boost by running in Node.js over Python for their Dilbert implementation, which is a significant speed boost just by converting with pre and post processing. Now, if we look at the superpowers on the client side, you can also see how some of these benefits are only possible by running on the client side in TensorFlow.js. The first thing is privacy. Because we're running in the browser, it means none of the sensor data coming from the camera, the microphone, or anything else is ever sent to the server. And that's really important if you're doing some kind of medical application or legal application, or maybe you're trying to deliver a solution to somewhere in Europe with all the GDPR rules, but are legal requirements to have privacy and for certain standards and all that kind of stuff. So with TensorFlow.js in the browser, you get the privacy for free. Second point is lower latency. Because you're not having to send all that data, and in the case of images, it's quite large, you don't have to send that data to the web server. That means you can save the round trip time from the client to the server and back again. And in the case of a mobile phone in the middle of a field, that could be a few hundred milliseconds, which is a significant time delay to get a result. Third point is lower cost. If you don't have to hire servers that are running 24/7 with big graphics cards, lots of RAM, and lots of processors, then of course you can save potentially tens of thousands of dollars per month by not having to hire those servers in the first place. With TensorFlow.js, we run on the hardware in the browser on the client side. The fourth point is interactivity. Basically, the web has been designed for interaction and the display of information and content from day one. So it's really good, and we've got really rich libraries for computer graphics, for charting, and much, much more. And then the fifth point is reach and scale. Anyone in the world can open a web link. The same is not true for someone trying to use TensorFlow on the server side. For example, you first have to understand Linux. You then have to install TensorFlow on the command line. You then have to install the drivers, the CUDA drivers from NVIDIA, and then you have to clone the GitHub repository and then understand their README file and hope it's written well to understand how to use that code. That's a big barrier to entry when you just want to try a machine learning model out and see if it's good for you. It's much easier just to click a link in the browser and it just works all the time. Cool. So the similar benefits are also available for the server side too. If you're running in Node.js, not the web browser, but in Node.js on the server side, then of course it allows us to use the saved models from Python without conversion. So that makes it really nice if you're working with a web engineering team to take the Python saved model and then use at scale with a web environment. It also allows you to run larger models than you can do on the client side due to the various GPU memory constraints on the client side. And of course, it allows you to code in just one language, which is JavaScript. And 67% of developers in the world, as of 2020, use JavaScript as their primary development language, as stated in the Stack Overflow 2020 developer survey. So if you're already using JavaScript, it allows you to stay using JavaScript. And that's really, really powerful because then all your code is in one language and it makes it much easier to maintain. Of course, there's a big NPM ecosystem, lots of modules to use. And then the fifth point we've touched on already is the performance benefits. We got the same inference times in Node.js as Python, but you also get the just-in-time compiler boost of JavaScript language when you convert the pre and post-processing to Node.js. So to wrap up here, I'm going to leave you some resources to get inspired and learn more. If there's one slide you want to kind of screenshot, let it be this one here. Essentially, this has all the links you need to get started. We've got our website on the top here. We've got all of the models that are available, the pre-made models. I showed you just 3 of our pre-made models today. We've got many, many more that are available on our website too. Lots of really interesting things from sound detection, natural language processing, and so on and so forth. TensorFlow.js is an open source project. It's fully open source. So we are all of our code is available on GitHub. And if you want to contribute, of course, we welcome pull requests. If you have technical questions, we've got a Google group. And if you want to get started super fast, we've made some code pen and glitch examples, like you saw earlier in my demos, that allow you to clone that code and start from a working boilerplate, which is really, really useful. And then if you want to go much deeper, this book, Deep Learning with JavaScript, is a great introduction. It goes from zero knowledge of machine learning to a very comprehensive knowledge of machine learning all in one book. It's about 12 chapters, and all you need to know is a bit of JavaScript, and it will take you from zero to the knowledge you need to get started. So really good book. And my only thing left to say here is come join our community. I've shown you just a couple of demos today, but we have new ones coming out every single day from the community. If you search the Made with TF.js hashtag, you'll see all the amazing things going on. And there's incredible amounts coming from India, actually. So many people from India are really getting involved in this right now, and it's great to see that. And I encourage you to check out their projects to see what's going on. And if you make something, please use the hashtag so you can be featured at our future events and show and tells and things like this potentially in the future. So the final thing I want to say here, one more piece of inspiration. This guy from Tokyo in Japan, he's actually a dancer by day, and he's used TensorFlow.js to make this really cool hip hop video, as you see on the slide. And my point for showing this is that machine learning really now is for everybody. It's not just the engineers and machine learning data scientists. It's actually for artists, creatives, musicians, and much, much more. And I'm really excited to see that TensorFlow.js can be part of this story, enabling everyone to take their first steps with machine learning, no matter what your background. So please do stay in touch. If you've got any questions, I'm happy to take them now. And of course, if you want to ask them later, I'm available on Twitter and on LinkedIn. Feel free to add me and let me know you found me in the show, as I get a lot of requests. So just let me know you found me here. Thank you very much. And I'll take any questions at this point. Thank you. And yeah, feel free to write in the live chat on YouTube if you have any questions, and I can read them from there. So what first question that came in is how to make an interactive GUI in Colab or Jupyter Notebook. So this is not Python, so we don't use Jupyter Notebook typically, but basically you can use things in glitch.com or codepen.io. These are websites that allow you to write JavaScript in the web browser, and you can make all of the GUI stuff in there and run it there for free. They're free websites to use, and it allows you to host websites that are powered by TensorFlow.js very, very easily. Second question, how to get started with making interactive photos using TensorFlow? Great question. I think that would be beyond the scope of a short answer. That's actually a very in-depth topic on how to do generative networks. You probably need to use some of the research from Python TensorFlow to do the GAN side of things, but you can then combine it with some of the TensorFlow.js models to then do some really cool stuff in the web browser. In fact, let me just share with you right now an example that I saw recently. One moment, let me just share my screen again. Present my screen like this. There we go. Let me find the demo. 1 second. I'm going to find it now. Of course, but I want to find it. I can never find it. 1 second. You can see here, I'm just going to bring up my Twitter here, and you can see I just searched the Made with TF.js hashtag, and if you sort by latest, hopefully we'll find somewhere here the Mona Lisa demo. Where is it? Let's see where it's got to. And you can see just a number of projects coming out of the community right now. There's so much stuff coming out here. Oh no, I can't find it right now. Okay, well, I'll have to send that in the chat later. I can't seem to find the Mona Lisa demo right now, but okay. I'll send the link around. If you want to find out more about the image manipulation, just add me on LinkedIn. I'll send you the demo for that. You can talk to the person who made that, who can give you way more pointers about image manipulation. In fact, we've got a blog post coming out soon for that, so stay tuned on the TensorFlow blog as well. My thoughts on the 30 series NVIDIA GPU. I think it's a pretty cool GPU. I'm definitely in line to buy one at some point. Yeah, I'm very excited about that. I have to wait and see when they come out. Is it possible to show the analysis or graphs of some TF modules in Glitch? So TensorFlow.js has an inbuilt API for charting. So if you want to plot like the loss and accuracy and all this kind of stuff we've got APIs for that in the browser, and it prints out these pretty graphs live on the web page for you, and you don't have to do much other than telling it what to print. So it's very easy to use. And if you go to the TensorFlow.js website, there's documentation on how to use the TF.js viz library, which is part of the TensorFlow.js library if you choose to include it. Please suggest some good web resources on TensorFlow. So, I mean, the obvious site to go to is tensorflow.org/js to find out about TensorFlow.js. And if you want to find out about TensorFlow Python, then just go to tensorflow.org without the JS on the end. And those are the two main websites for TensorFlow. Can we connect on LinkedIn for some projects? Yes, please feel free to add me on LinkedIn and just mention that you met me here today, as I get a lot of requests and it's hard to filter out who's who. Cool, I think that was the last question. Is the book available online? There is a digital version of the book, yes. I believe it's available in online format or PDF format. However, it is a paid book, so you do have to pay for it, unfortunately. So yeah, it might be, I think a few chapters are free to sample, and then if you like it, then it's possibly available to then buy. How to start from scratch. I would advise you to start by playing. Try out Teachable Machine that I just showed you. I guarantee you, once you recognize the first object in your room and you realize that you can recognize it very accurately, you feel like you've got superpowers. And then it's just a case of being creative and trying to solve problems in your life, basically. So like, find a problem in your life that you think you could solve by using one of the models that I've just shown you today. And more often than not, you can make something. Like my clothing size estimator. I had a problem. I couldn't manage to find the clothes in the size that I wanted. So I solved the problem by using TensorFlow.js. So just think about things in your life that might be optimized by these kinds of models. Do you have any in-depth courses online? Great question. Some of my colleagues have made courses for TensorFlow. Lawrence Moroney, for example, has made a great course on TensorFlow, and there's some references to TensorFlow.js as well. Some of our community and GDEs have made some stuff too. Gantler Board has made a great introduction to tensors and all this kind of stuff as well for TensorFlow.js. I highly recommend that. All of these people are available on Twitter and LinkedIn as well. If you just search their names, you'll find their course content. Python versus JS, which do you prefer and why? Well, I'm obviously very biased here. I am the developer advocate for TensorFlow.js specifically. So of course, my answer here is JavaScript. I am a big JavaScript fanboy, but honestly, use whatever you're comfortable with. As I've shown, you can use Python-based models in JS by converting them, and use what you're comfortable with. I'm not going to give any forcing you to do anything there. Just use what you like. But my preference is JavaScript. I find it to be more creative for rapid prototyping and that kind of stuff. Cool. I think that's all the questions. If there's any more questions, feel free to keep them coming. Else, we'll wrap up in 2 minutes. I'll give you another minute or two to ask any more questions. Is TensorFlow.js better for text image processing? No, and it's not really better or worse. It's just in a different platform and a different language, right? So you can take a TensorFlow Python model and convert it to run in TensorFlow.js. It's basically the same model, so there's no real difference there. It's just running in a different environment. The advantage of TensorFlow.js is that you can run it in many different environments without having to change your code, such as in the web browser or in a native application or in a Raspberry Pi. And you can just write it in JavaScript once and then deploy to all of these different endpoints, which is why I like to use it in that way, basically. If you're using Python on the server side, then you're limited to the server side only in that situation, or you have to deploy in other ways, maybe using TensorFlow Lite or something like this. What are my views on deep speech? That's a good question. I don't have any views on it. I mean, I think it's an interesting piece of research, and I'm sure we're going to see more research like this coming out in the future, and I'm excited to see where it goes. I think it could enable a lot of interesting things for accessibility and to make those kind of text-to-speech kind of readers much more enjoyable rather than having those robotic voices and things like this. So it'd be interesting to see where that goes. Can we train live, as in post it on a website and keep users updating the machine, or will we have to train manually, like how you showed with the card and webcam? So yes, I mean, you can train it however you wish. you can choose to do a large data set in Node.js on your own server in the cloud or on your own local machine, and then you can take the resulting model and deploy it to the web. That's one path. Or you can do something like Teachable Machine, where you do the training and the inference all in the web browser without even touching a server. And that's one of the flexibilities that you can choose to have with TensorFlow.js. And there's some use cases you might want to do that when you're training custom models for certain things in the browser. That might be useful to do it in that way for privacy or something like this. So it depends on what you want to use it for, essentially. How does Google use TensorFlow.js? Many different ways. You've seen some of the demos I've shown today, but we're using it in many of our other products and services. I know that Magenta, which is looking into art and machine learning and creativity and machine learning, they're using TensorFlow.js to show off all their demos in web browsers to get the reach and scale of the web. And I highly recommend to check out Magenta. Actually, it's a really cool project, and they can do all this kind of music generation, music instrument stuff. And I don't know if anyone, sorry, I don't know if any of you saw the Sounds of India project that came out recently. That allows you to sing the Indian national anthem, and it converts your voice into a classic Indian musical instrument, like a sitar or something like this. So it's really, really cool, and it's all powered by TensorFlow.js in the browser. How does Google hire employees for machine learning? It's the same as any engineer at Google. You have to go through lots of interviews and basically show that you're the best at what you do for that kind of stuff, I guess. So build up your portfolios and check out google.com/jobs if you're interested for careers at Google. Does TensorFlow use C++ API? So I represent the TensorFlow.js version of TensorFlow, so I can only answer questions about the JavaScript implementation. Behind the scenes, though, TensorFlow does use C, but Python and Node both talk to those C libraries behind the scenes. So yes, ultimately it's in C, but like a lot of these other languages use the hooks to that underlying infrastructure in order to just make it easy to integrate with Python and Node.js and other things. Can TensorFlow be deployed in container software? Are you talking about like Kubernetes and that kind of stuff? Can you just clarify? I'm not sure if you're talking about like Kubernetes. Yeah, I mean, they can be used in this kind of context for sure. A lot of web devs and things use kind of these kind of container-based packages and things like this to deploy their ML services and things at scale and have it auto scale in the cloud and that kind of thing. So that is definitely possible. How does TensorFlow make use of Python API? I don't know. I don't use Python. I'm JavaScript, so I can't answer that question. Sorry. Cool. I think that's all the questions for now, though. Thank you very much for watching. And if you have any others, feel free to add me on LinkedIn or Twitter, and we can always be in touch over on there as well. And yeah, I put a lot of posts on there around machine learning, creative technology, and all this kind of fun stuff. So I hope you enjoy the post as well. I'll hand it back to the event hosts, and you can close up. Thank you very much.
Thank you, Mr. Jason, for your wonderful session on TensorFlow. That was really an informative session, and we're looking forward for more conversation through Twitter and everything. And I would like to thank from Vidyalankar Institute of Technology and CESA team for providing such a nice platform for sharing the information and being benefited by knowing the information regarding TensorFlow. Thank you so much. Over to you, Bhargav.
Yeah, so thank you so much, sir. It was a really amazing session, and I really personally like that. I am in machine learning. I basically use machine TensorFlow model, TensorFlow library, but I haven't tried the JavaScript library yet. So I will definitely try, and I will explore some more features which are in this library. And thank you so much for joining this webinar organized by CESA VIT. And over to Suja, ma'am.
Awesome. I look forward to seeing your submissions on the Made with TFJS hashtag.
Yeah.
Good stuff.
Thank you, sir. Thank you, sir. And thank you all the viewers for watching our
One more thing that the
and our program.
ma'am, one more thing that the feedback link is in on the
Feedback
screen,
form.
as well as you will get in the chat box. So fill it.
Yes. Fill the feedback form for further improvements. Okay. Thank you, everyone.